Hello and welcome to the Daily Space. My name is Dr. Pamela Gay, and most weekdays I am here to put science in your brain. But today is Wednesday, and Wednesdays are meant for Rocket Roundups. Let's get to it, shall we? First, SpaceX's Cargo Dragon 2 that flew the CRS-21 mission launched on December 6th of last year splashed down on January 14th at 1:26 UTC in the Gulf of Mexico, west of Tampa, Florida. The automated cargo capsule undocked from the International Space Station at 14:05 UTC on January 12th, carrying about 2,002 kilograms of cargo. The undocking was delayed by poor weather in the primary landing zone in the Atlantic Ocean northeast of Daytona Beach. Now, if this seems to be a weird place to land, you're right. Splashing down closer to Florida allowed SpaceX to return time sensitive cargo to NASA's Kennedy Space Center within just 4 to 9 hours, compared to previous Dragon cargo missions that splashed down off the coast of Baja California in the Pacific Ocean, which can take several days to return to NASA. This marked the first return of a Cargo Dragon 2 spacecraft. The new Cargo Dragon 2 is based on the Crew Dragon design, but with a different pressure vessel to accommodate additional volume. Cargo Dragon 2 lacks the Super Draco engines used by the Crew Dragons because it doesn't require the launch escape system, and getting rid of them allows for more space in the capsule. However, Cargo Dragon 2 retains the fins of the Crew Dragon trunk design. This is because changing the aerodynamics of the capsule is a major change. The fins also provide space for solar panels and radiators necessary for spacecraft function. Among the cargo returned were live mice. This is why they wanted to get things back quickly. These live mice were from the Rodent Research 23 experiment. They also had a dozen bottles of space-aged French wine. The wine bottles went up onto the International Space Station on a Cygnus supply ship in late 2019 and spent more than a year on the International Space Station. Some of the bottles will be opened for a very exclusive tasting, but most of them will be analyzed to determine how wine aged after more than a year in microgravity. There were also 320 cuttings of grapevines as part of a privately funded experiment led by Space Cargo Limited, based in Luxembourg. And these were to learn how the plants adapted to the stresses of spaceflight. The knowledge learned from this experiment could provide insight into how to grow grapes in the harsher environments on Earth. This image shows the CRS-21 capsule re-entering. It was taken from Shell Point Beach, Florida. At this point, the capsule was about 10 minutes from splashdown. The photo was taken by Twitter user Matthew Bull at MadeOnEarthFoo1. He gave us permission to use it in the show. We are so grateful, Matthew. On January 14th at 16:57 UTC, Blue Origin launched their new Shepard 14 mission from their Corn Ranch spaceport in Van Horn, Texas. Both the capsule and booster were new. The capsule featured astronaut experience upgrades, which included speakers in the capsule, microphones in each of the 6 seats, and cushioned wall panels to reduce ambient noise in the capsule, and an environmental control and life support system to support the passengers, including humidity and temperature controls to regulate temperatures and prevent fogging of the windows. Now, before I continue reading, I want to remind everyone this spacecraft is intended to carry tourists into space. So some of the things they're doing is simply to allow people to, well, have fun on their way above the atmosphere. One of the improvements to the crew experience on this flight was the addition of a 2 degree per minute spin on ascent to allow passengers a full 360-degree view on the way up. More than 50,000 postcards contributed by Club for the Future, a Blue Origin sponsored club to encourage children to pursue STEM careers, were also carried inside the capsule. They also had a Mannequin Skywalker, an instrumental crash dummy that was strapped into one of the seats. The capsule reached a height or apogee of 107 kilometers, while the booster reached a slightly lower apogee of 106 kilometers. Total mission elapsed time was 10 minutes 10 seconds, and both capsule and booster landings were successful, though the booster touched down off center on its landing pad. We have videos of both of these to show you right now.
4. Command engine start. 2, 1. Ignition.
From that dramatic takeoff, we now can go and see first the booster return. This is an extremely reusable model of a spaceship.
Engine restart. Landing gear deployed. And touchdown.
Well, that was truly amazing. No humans actually fly on that. So if you were thinking, I don't want to be on something tilting and tipping that wildly, it's okay. The way they bring the astronauts back down to Earth is a little more familiar and a lot calmer to watch.
What a beautiful shot. You know, Mannequin Skywalker, I mean, if he had adrenaline, his heart would be thumping pretty hard. What a day. All the way up over the Kármán line and back, coming in for a nice soft cruise back into our West Texas Valley there. Just about 400 feet above ground level. We're waiting for the retrothrust systems to fire, and then a nice soft landing. And touchdown.
With that beautiful landing, we can see a future of space tourism becoming significantly closer. We don't know when they're going to be able to start launching humans, but now we can imagine it will be possible. We're going to take a break, and when we come back, we're going to talk about the latest rocket to make its way up into space. There is a new, finally demoed successfully rocket in town. On January 17th, Virgin Orbit conducted their Launch Demo 2 mission of their Launcher 1 rocket. The modified 747-400 Cosmic Girl lifted off from Mojave Air and Spaceport in Southern California. It took off and headed south over the Pacific Ocean. Launcher 1 was then dropped from the left wing of Cosmic Girl and climbed to orbit. Unlike the first mission, first stage burn, main engine cutoff on the second stage burn, coast, and restart all occurred normally, nominally, in space terms, and Launcher 1 became the first air-launched, liquid-fueled rocket to reach orbit. Air-launched orbital rockets are not a new idea, and the Orbital Space Sciences, now Northrop Grumman Innovation Systems, Pegasus rocket first flew in 1990, becoming the first privately developed orbital rocket of any kind. What makes Launcher 1 unique is the propellant. Pegasus, its predecessor, uses solid fuel on all three of its stages, while Launcher 1 uses liquid fuel on both stages, which allows it to more easily shut down its engines if it needs to. Basing the design on Pegasus holds true to the pedigree of many of Virgin's space vehicles. Burt Rutan, who designed Spaceship One and Two for Virgin Orbit's sister company, Virgin Galactic, also designed the wing on the Pegasus first stage. We have a video of this launch that we will show you in just a moment. Virgin Orbit originally planned to launch a dummy payload on this flight, but after a lot of analysis and discussion with NASA, the decision was made to fly 10 CubeSats on this flight. They were under contract for NASA's Venture Class Launch Systems. These satellites are part of NASA's Educational Launch of Nanosatellites initiative, which is designed to attract and retain students in science, technology, engineering, and math disciplines. All these satellites were successfully deployed. While we can't talk about all 10 satellites deployed by Launcher Demo 2, we do want to mention a couple of them. The first is Cactus One, a 3-unit CubeSat from Capital Technologies in Laurel, Maryland. It will be carrying out 2 technology demonstrations, Project TRAPSAT and Project Hermes. Project TRAPSAT is the main science component of the satellite, with a goal of trapping micrometeorites in an aerogel medium to better map the existence of micrometeorites orbiting the Earth. Project Hermes will be the main communications component of the satellite, flying under a different name, OSHCOM, the Onboard Spacecraft Hotspot Communications Subsystem. OSHCOM will communicate with the ground through satellite internet via the Iridium constellation. This means that unlike conventional CubeSats, the communications coverage with the satellite will be global, 24/7, and accessible from anywhere with an internet connection, allowing the Cactus One team to command and receive data from their satellite from any computer, laptop, or smartphone at any time. The other satellite we want to mention is TechEdSat-7, a collaborative engineering project between San Jose State University and the University of Idaho with oversight from NASA Ames Research Center. TechEdSat-7 is a technology demonstration mission that will further develop the exobrake system by testing a high packing density exobrake. In addition to exobrake, it will demonstrate a CubeSat identity tag, which is a DARPA RFID system that will aid in the identification of nanosats, including ones that have ceased to function. If you would like to learn more about the other satellites in the Alana 20 mission, check out our show notes at dailyspace.org. On January 19th at 1624 UTC, China launched a Longmark 3B carrying a Tiantong-1 O3 satellite from the Kaishan Satellite Launch Center in China. The Longmark 3B has 3 stages and 4 side boosters on the first stage. This is a truly impressive looking rocket. Let's take a look at its launch. This mission carried a Tiantong-1 communication satellite successfully to orbit. This is the 3rd satellite in this constellation, joining the Tiantong-101, which was launched in August 2016, and the Tiantong-102, which was launched on November 12th of last year. The Tiantong-1 satellites are geostationary mobile communication satellites operated by China SATCOM and are the country's answer to the Inmarsat network. They provide stable satellite phone coverage in all weather conditions for China and the surrounding areas. Reportedly, they carry an S-band mobile communications payload with a large unfurlable dish antenna, which you can see depicted in this artist's rendering. They are fairly heavy satellites weighing in at 5,400 kilometers. We're going to take a break, and when we are back, we're going to talk about the Artemis test that took place over the weekend. Finally, for this week, the long-awaited green run for the Space Launch System core stage occurred on January 16th. The test was set for the afternoon, and after several delays, the 4 RS-25s on the core stage finally ignited. They began what was supposed to be a 480-second burn, but the engine shut down after only 67.2 seconds. This was at the point where the stage computer was to start commanding the engines to go through thrust vector control checks, moving the engines around. Just before the moment of shutdown, an engineer could be heard saying, "MCF on engine 4." After the test above, Wayne Hale, the last shuttle program manager, took to Twitter to explain that MCF means major component failure. MCS means time to end an engine firing, according to Hale. Let's take a look at a segment of this test.
There we go, engine start. And we're in the press count. Engine start. We're in the press count. Call for south, please continue to monitor your system, and grass is in control. All right, plus 25 seconds.
It turns out the actual reason for why the engine shut down had nothing to do with the major component failure on engine 4. According to a NASA blog update published on January 19th, the actual reason for the aborted firing was that one of the engine's TVC systems exceeded its preset limits. The limit was intentionally set low to keep the vehicle safe during the ground firing and would not have resulted in a shutdown in flight, according to NASA. This is a particularly unusual rocket test. The hardware that they are testing is the exact same hardware that will be used for the Artemis 1 first mission, which is slated to go all the way around the moon. This is a big planned launch, and this is the rocket they've got, so they're trying not to test it to the extremes because they want to protect it. Before the tests, NASA said that they needed at least 250 seconds of firing for a successful test. The test firing had 23 objectives, and the 67.2 seconds of firing fully completed just 15 of those objectives. As of the update on January 19th, teams were still investigating whether a second green run was necessary to complete the objectives. Key to the decision is the fact that the Space Launch System's core stage is only designed to be tanked with super cold liquid hydrogen fuel a total of 9 times. The vehicle has already been tanked 3 times, 2 wet dress rehearsals, and this green run. It will undergo another wet dress rehearsal when stacked at Launch Complex 39A and will be fueled again at launch. All of these fuelings make it more difficult to decide whether to do another green run, and as of press time, a decision had not been made. So we wait and we see. But for now, that is, for the most part, what has happened in the past week. To wrap things up, here's a running tally of a few spaceflight statistics for the current year, current as of midnight last night. There are currently 5 toilets in space, 3 installed on the International Space Station, 1 on the Crew Dragon, and 1 on the Soyuz. There have been a total of 13 satellites launched. And so far, 2021 has seen 4 launch attempts. We keep track of orbital launches by where they launch from, also known as spaceport. Here's that breakdown. The US has so far had 3 launches and China has 1. There were 2 additional launches since midnight, a SpaceX Falcon 9 and an Electron. We will cover both of these missions in detail next week. Your random space fact for the week comes from CosmoQuest community member Uncle Willie. During the closest approach to the sun, the Parker Solar Probe will be traveling so fast that it could go from the Earth to the moon in about 50 minutes. New Horizons, the previously fastest spacecraft, took 9 hours to cover the same distance after its launch. Now, to be fair to New Horizons, the Zippy Explorer did get sped up on its way to Pluto, in particular by a gravitational assist from Jupiter that helped it exceed 52,000 miles per hour. Still, Parker's solar probe is going closer to 300,000 miles per hour. This tremendous velocity is required to allow the mission to fly past the sun without the sun's gravity having a chance to pull it in. According to Jonathan McDowell, Parker's most recent closest approach to the sun, or perihelion, brought it within 8,400,000 miles of the sun. This is the closest any man-made object has passed to the sun. This is not the closest or fastest that Parker will go, however. In 2024, it will get within 3.8 million miles of the sun while traveling at 430 some odd thousand miles per hour. And when it happens, we'll bring it to you right here on the Daily Space. For now, though, this is all we have for today. Tomorrow, we will be back with more space and astronomy and a rundown of what will be worth seeing in the sky over the weekend. Thanks. Bye-bye, everyone.